The next topic in vectors is scalar multiplication. A vector can be multiplied by a real number. So there are some examples below in figure 6.52 that shows a multiplication of 2b. So here's your original vector b in the black. And if we want to multiply it times 2, we just stretch that twice the original amount. If we want to multiply it by 1/2, we're going to shorten it by half the original length or magnitude. The last one is a negative 3/2. What that does is going to change the direction. So when you multiply by a negative scalar, it's going to make the direction inverse. So now my vector is going down, and then multiplying it by 3/2 is 1.5, the original amount. So you can pause and look at that in more. All right, so here's the rule for scalar multiplication in the yellow. If k is a real number and you have a vector b, the scalar is that k value. K times v is called the scalar multiple of vector b. The magnitude and direction are as follows. So what you do is you multiply the k value times the vector's length. If your k value is positive, you're going to have the same direction. If the k value is negative, then you're going to go the opposite direction. So looking back on this previous slide, this red one had a negative k, so it changed the direction. Where the two in the green and blue have a positive k and a positive k, so they're going to stay in that same north direction. All right, continuing on. Geometric method for adding vectors. So here's a figure 6.53. Where if we add two vectors together, you call that the resultant vector. So adding of two vectors is called the resultant vector. So here's how it might look like. You have vector u. So here's your vector u, and then here's your vector v. For those two to connect, the resultant vector is u plus v. So this is the resultant vector. And how that looks is the green vector is your resultant. The difference of two vectors, so you're subtracting them. So v minus u. So here's vector v, and you're going to subtract u. So you're going in the opposite direction. So here's the original u. This is vector u going to the right. What happens is it goes in the opposite direction, backwards. And then the resultant vector is right here, where those connect. So this is your resultant vector. All right, I think I'll stop there.